Claire. Today let's talk about the first video of the Cardano formula. Okay, so we know we have several videos of Cardano formula. So this is the first video. So about Cardano formula, we know it's about we know you're gonna find the root of a cubic equation, right? Through x. So this is the ordinal form as you write a cubic equation. So we're gonna let equal 0 and find the root. Okay, so the first thing we're gonna do about Cardano's formula, the method actually, it's a method. So, you know, what we're gonna do is to first step equals 0. So we're gonna do the both sides divide a, so xc3 plus. So here's supposed to be lowercase b over lowercase a, and we set this as uppercase b, okay? Okay, then x where? And so here as we set, okay, so this is supposed to be lowercase c over lowercase a. So we set this as lowercase p, okay, and then lowercase d over lowercase a. So this is what it's supposed to be, and we set this as lowercase q. Okay, so this is what it is. So the next step we're gonna think about is, okay, so what's Cardano method doing is to change this. We're gonna change it to another cubic equation and let the quadratic term disappear. So we're gonna do it together. Okay. So what I think about actually is doing is to set something like this. So x, we're gonna set another. We can change x to another variable, but this variable is gonna plus an h. Then it can change to x. Okay, so let's think about how can we just we basically gonna actually plug it in, right? Okay, so then we have two. Actually, we had two. We can use the binomial. We're going to use binomial expansion. So we have two parts of the y2. Then we're gonna let them be canceled. So you know, then the quadratic part of when the variable is y will disappear. So that's what we're gonna do, right? So first we're gonna think about a binomial coefficient. Binomial. We just plug it in and have the binomial expansion. So we have y plus h, and the whole thing to be 3. And we're gonna plus b multiple of y plus h bracket to 2. Okay, and then plus p multiple of y plus h. This is h. Okay, not b. Okay, h. Okay, and then plus q. Then we're gonna let it go 0, so whatever it says. So we're gonna think, okay, so what if it is 1, 2? We're gonna use the binomial expansion, right? So this is y to the 3. I'm gonna plus y to the 2 h. And we're gonna plus another, sorry, here's 3 multiple, right? Because you're doing binomial expansion, 1, 3, 3, 1, right? So this is 3, and this is y times h to the 2, and then plus h to the 3. Okay, and then plus, so this part is by to the 2 plus 2by h, and let's have a look. And another part is gonna be plus bh square, right? That's it, and then plus py. Sorry, here's supposed to be this, right? Okay, so py plus ph. Okay, and then plus q. So here's the point. Okay, so if we have this thing about it. Okay, so now I'm gonna pick the cubic part and the quadratic part and the linear part and the constant part. Okay, so what is that? So the cubic part, of course, only y to the 3 is term, right? We're gonna plus. So over here, the quadratic part is this one and this one. So we have 3h plus b bracket y to the 2. And we're gonna pick the linear term. So first this is so this is h, right? So this is 3h square, and then and this is the constant term, and this is also so plus 2bh and then so this term, and this term to plus p. Okay, so the whole thing times y, and then so now we're gonna think about a constant term, right? So the constant term, look, this term, so h is 3 and plus b ht2, and then plus p h plus q. Okay, so this is the whole thing. Okay, so now our aim is to let this part equal 0. So then we'll find out h is equal to so b over 3, right? Sorry, it's negative b over 3. So the point is over here. Okay, so this is negative b over 3. So what we're going to do? Okay, so negative b over 3. So if we plug it in, we will have this part has been cancelled. Okay, and we'll have yt3 plus, okay, so 3x squared. Then that is negative. So one of the 3 has been cancelled out because it's on the denominator, right? And we'll have another 3. And then we have a, sorry, because this is squared, so we don't have a negative anymore. Okay, so then we have b squared over 3. And I'm going to plus, so this is supposed to be minus, right? Negative and minus, right? So 2b, okay. So this is 2 over 3 multiple of b squared, uppercase b squared. Okay, and then plus p. The whole thing y, and then times y, and this constant part with this whole thing squared, so negative, b to the 3 and over 27, and then plus, so what about this whole thing? This is, so this whole thing squared, and then so times b, so we have plus b to the 3 over 9, and plus, so ph, that's supposed to be minus. Okay, so b p over 3, and then plus q. Okay, so in this case, we'll have this. Okay, so this is a cubic equation that has no quadratic term. Okay, so when we have this, we're gonna set it as y to the 3 and plus uppercase p y plus q. Then that's equal to 0. Okay, this is what it is in mapping. So this whole thing is uppercase p, and this whole thing is uppercase q. Okay, so when we have this, what's next? This is the situation that Cardano brings up. Okay, so what's the next step? We're gonna figure it out. Okay, so what we're gonna do, what he think about is, okay, then what we're gonna do is to change y to 2 variables. So what we're gonna do is we can set y as, you know what? We can set y as m plus k over m, or y equals u plus v. So u plus v is, we're gonna think about, they can just change their value. Well, I'll explain it in this dimension. Okay, and this is the same. But what do you say? Okay, so this is, if you know about graph, you say, okay, so this is a Hooke function. What do you just want to set it as a Hooke function? That is important because a Hooke function, I just write when x is squared than 0, okay? This thing looks like this. Okay, so if, for example, if I choose this x value and I have this output y, and what I'm going to do is because actually I have the same output y, but mapping it a different input x. So one output y in a Hooke function has 2 different input x. So, okay. So if we have this, then I'm here. Okay. So let's try. Okay, so let me just think about it. If I have a function x plus 1 over x, I don't make this. Okay, so x over k over x plus k over x. Okay, so if I have this whole thing, then what can X choose? So normally we can choose j, right? So we can choose a j, then this whole thing becomes j plus k over j. And in this situation, x choose k over j. So the left part is k over j, and the right part is j. So these parts are the opposite. Okay, so this is what we said as a hook function. So you know the step of hook function and that function were the same. Not function, just this set would actually the same answer. Okay, so let's think about. Let's see. Okay, now we're gonna set. We're gonna plug this in over here, right? So, binomial expansion. Sorry, here it is minus. Okay, right. Okay. We can write it as plus negative k over m. Okay, we'll see. Okay, so then think about, all right, then we're gonna do this 3 and plus p multiple of this whole thing. So thing is already here. What I'm gonna do is to move q over there. So I'm gonna set this as negative q. So let's go q. Okay, so I don't write q, right? Okay, so we're gonna think about this. So we're gonna think about how we do this. So first, 3, we have m3 plus so negative k over m, the whole thing 3, and then plus so 3 m 2 negative k over m, and plus 3 m times negative k over m bracket square. Okay, and then plus this whole thing. Okay, so we're gonna do is think about, okay, so first we have m3 plus negative k over m, the whole thing 3. Okay, so we're gonna plus. So this part and this part, we can just factor out this 3m times negative k over m. And then if we bring out this left, so the bracket is m plus negative k over m. So, in this case, these two parts are the same. We can just factor out this again. Then we have 3m negative k over m plus p, and the whole thing 3 times m plus negative k over m. Okay. So in this case, what this do is to let this whole thing equal to 0. So what is that? Why is that? I'll explain in this dimension. Okay, so let's just prove it first. Okay, so if we have this condition, would this whole thing equal to 0? No meaning. Of course. I'm going to set it as u plus v. That's the thing. U plus v, bracket d3 plus p, p times u plus v. Okay, so in this step we'll have is equal to k, so u d3 plus v d3, and plus 3 u v, sorry, u squared v, okay, and 3 u v squared, and then plus, okay, so p times u plus v. So what we're going to do is we can change to u squared, u d3 plus v d3, and plus, okay, so here it says 3 u v plus p, and then u plus v. Okay, so let's think about, we let this whole thing go to 0, right? Of course, this is equal to q, and this is also equal to q, so we'll let this whole thing go to 0. Okay, so we're going to do this whole thing equal to 0. We can't let this part equal to 0. the no meaning because we set it as this. We're gonna find out value of y. Okay, so we said there's no meaning. We let this thing equal to no meaning. We're gonna let this whole thing equal to 0. So if this whole thing equal to 0, so then u times v by this condition. So that's gonna negative p over 3. Okay, remember. And in this case, then we have ud3 plus vd3 equals q. If this whole thing is 0. Then we're gonna say something. We're gonna set that u, uppercase U, is equal to lowercase u to the 3, and then v, uppercase v equals to lowercase v to the 3. Okay, in this case, then uppercase u times uppercase v, that is equal to this whole thing squared. So this is negative p to the 3 over 27. Okay, and what about here? Then we have uppercase u plus uppercase v, that's equal to 0, right? Okay, that's, sorry, q. That's correct. So these two conditions just as the Vieta's theorem of the quadratic function. Okay, so then in this case I can create a quadratic function that the variable was t. So t to the 2 plus, so then this is supposed to be minus p3 over 27 times t and then plus q. Okay, so I can use that formula. So negative b plus positive negative square root b squared minus 4ac over 2a. Okay, so first let's have a check. Okay, so negative b. Okay, so b is already negative. So then that's positive p3 over 27. Sorry. This part I just messed up. It's supposed to be plus q and then gt and minus p3 over 27. Okay. So negative q, and the whole thing of course is over 2 because a is equal to 0, right? So positive negative square root. So okay, so b squared is q squared, and then minus 4ac, so 4a, a is equal to 1, and c, so we're going to plus because c is negative. Okay, so 4 times c, so 4, and then 27, and so p squared, okay, p3. Okay, so in this case, what is this equal to? Because we can just break it into 2 parts, and the right part we can put 2 into the square root, so negative q over 2, and we're gonna positive negative square root. So in this whole thing, you see, we'll put it over here. So this is actually q over 2 whole thing is to be 2, right? Square. Okay, and this is a whole thing to be cubed to be 3 because you see they cancel out, right? So have p over 3, the whole thing to be 3. Okay, so this is it. So lowercase u and lowercase v is going to be the cube root of this whole thing. So lowercase u is equal to cube root negative q over 2 positive negative square root q over 2 bracket square plus p over 3 bracket 3. Okay, and then v, lowercase v equal to cube root, and then negative q over 2, sorry, here is supposed to be only positive, and this is choose negative, so q over 2, bracket 32, and then plus, okay, so this is it. So the answer of the, unit root of this, then we'll calculate it, plus them together, and we have the answer. And the next video we'll talk about, we say, okay, so, a quadratic function has 3 roots. So next video we'll talk about the other 2 roots, how to calculate it, okay, how to find it. In this video, we'll just talk about here, and don't forget, if you find a u plus v, that's only y. We're going to do, don't forget, you're actually going to find x. So don't forget to plus a h. That means don't forget to minus b over 3. Uppercase b over 3. And uppercase b is lowercase b minus lowercase a. Okay, so this is it. Okay, so this is what we're going to talk about today. Okay, so here's something I'm gonna add. So first, don't look at the backboard. Of course, I'm just telling you, it should be Cardano equation, not function, okay? Okay, let's just keep what I'm gonna add, because I say in this 3-dimension, because we let the middle part equal to 0, right? So what is this? Why can we do this? So we're gonna have a look in the picture from my iPad, okay? And look at this picture. It's about the original function. Look, the original function over here. It measures to this function. And it looks like this. Then this has to be symmetry. Okay, look, this is x and this is y. Okay, it just got some problem. All right. So we can just move this. Okay, and looks just like a plan, right? So this plan, it is about like this function, and it has to be, because we're actually thinking about, look at over here. So we're actually thinking about let this function equal to 0, so we can think about when z always equal to 0. Then we have to think, and this you actually can say this is x-axis, so that's u-axis, and this is y-axis, and so that's v-axis, for example. And okay, take a look over here. We'll have this picture, and this is what we think about. For example, think about when z is always equal to 0. And if we have this, then we're gonna think about the root that it's we can opposite u and v. So these two roots, for example, here, and when we choose here, and this is u choose b and v choose a, and when we choose this point, that is the v, u choose b and v choose a. Now, if this happens over here, let's take a look. So when we have in this over here, we're gonna think about in this line. So we know it has to be symmetry. Think about this line. It has to be symmetry with v equals u, this line, because this line is that if it's symmetry with this line, then these two guys can change their axis, but not just the whole picture change, just these two axes change, then these two values can just opposite measure to the u and v. Okay. Now this is the point. So you ask, oh, now what happened? I'm gonna let this equal to 0. So what will happen? So let's just think it after this. Let's just think, because it has to be symmetry with. We know we has to be symmetry with this line over here. It's that u equals v, but you can imagine that when z choose any value, it always has to satisfy this. Then we can take a look on the picture, because we can move. Okay, not because we can move. For example, you can see over here, that is, for example, we choose z equals 4, then it's over here. This whole line we're going to think about, right? Okay. This line. All right, then we have to think about this line over here. Okay, now this line, then this has to be symmetry over here about the, actually we're going to have to think about the plan of as I say, this line, so we can actually create it. So this function is the last one. It is x minus y equals 0. Now I told you why, but let's just look at. Look, it's just symmetry with this plan, right? Look at this plan. Okay, so here's something I'm gonna tell you. It should be look like this, right? Okay, let me tell you something, because we're gonna look here. So when I was little, I talked about this. How can we define a plan? So we can write over this, and we have a P, that's X, Y, Z. This is what we're going to find, and P1 is a point that we already know, that we know on this plan, and that's 0, 0, 0. That's the easiest one. n, we think about vector n, then that is k, negative k, 0. You can just think the easiest one is 1. Negative 1, 0, but z, of course, it's be 0 because we need a direction, okay? And so, of course, it can't be 0, 0, 0. So there's no direction, so we can't let k choose 0, right? And just like this, k, negative k, 0. And we can just plug it in, and we have, of course, this is equal to 0 now because p1 is 0, 0, 0. So we have this one, so that's, because c is equal to 0, so over this part is gone, and we have kx equal, minus ky, and that's equal to 0, so both sides cancel, so we have x minus y equals 0. Actually, that's x equal to y. Okay, now let's keep looking at the figure. Now, the next step is to look at the next function. Okay, let me just cancel out this. Okay, this is when we let the middle part equal to 0. Now we have this function. Look, this function is also actually symmetry, as I said, with that x equals y plan. Okay, now let's move over here. Okay, now look at these two plans. So we have these two plan. We're going to think about. Actually, what we're going to do is to find out the root of this straight line that we think about. But this is out of this. And look over here, just getting out. So, what we're going to do is that because we are finding the root of this. But whatever we do, we cannot find the root. This is the point. We cannot find any two roots. Okay, so here's the point. You say, okay, and that's two different roots, but here's the point. Let's see. If I just choose this point, so that's B, and A, and this is B and A. If you think about this, then when we move over here, move a little bit, and because this is perpendicular to u equals v, then this slope of it must be 1. Negative 1. So these two, because if I said this is h, then this is also h. They're same now in this case because the slope is negative 1. Okay. Now, so over here, let me just write. Okay. Then we will have, because first it is a plus b, and now it turns to, because a is just going to minus h, right? So it's a minus h. Okay, a minus h. And then it's going to plus. Now it's b plus h, because b is negative value going to be higher, so that's plus, so b plus h. Okay, so this is also equal to, actually, they are equal. They're the same. So that's why. Actually, we only have to find a pair of that we can change u and v. Then actually their sum is all, because we are actually just going to find x, so we just change it to u and v. But we only have to find one pair, and then there's the sum of u and v. Is that what we want? This is the only root. Okay. So let's go back to the picture. So the point is that we have to find the root of the straight line, but we cannot actually plan, right? But we cannot. We cannot find even just one pair of roots. Now what we do? We just use this. The point is we need to have a condition when let this part equal to 0. When you just, for example, we just let x, y, u, v times them together, it is equal to a negative p over 3. This is a condition, and using the condition, we can find out. Using the condition, and we can find out the root of this function. You ask, oh yes, I just find out of this figure, this surface, right? I only can find out the root of this surface, not this first. The ordinal surface. I have to find the root of the ordinal surface. So how can we do? Actually, you see, we have these 2 points. Look over here. We have this point and this point. This is the intersection line. From the intersection line, the 2 points. We need this 2 points. And because we use the condition, it's u times v equals a number. We use this condition. Then what we find out, the 2 roots, is actually these 2 intersection points. Okay, this is how can we find out, because we have this curve and we can find this because we can use some kind of, we can say some method. We can just figure out how to solve using this surface and using this surface with the condition, we can find out the root. Only the root on these 2 points, because as I say, their sum are always the same, and I figure out these 2 points, this 2 symmetry point. That is how I can find out. Okay, this is what I'm gonna add. Of course, remember this equation, not function. Okay, so this is what I'm gonna add. Just telling you about it. And the 3-dimension figure. Okay.